Okay. So here are our two formulas. I'll write them up here. And you need to know which one to use. And what all those things mean. So those of you that did not watch the video, you're at a disadvantage. So you might want to go back and do that. So here we go. I'm on the side that I guess they're numbered. So number one, how much will she have when she's 32 years old if she deposits $500 right now in an account paying 2.4% interest compounded monthly? Which formula? Number one or number two? Two. Compounded monthly. So I'm going to use this formula. So how much will she end up with? If we start with 500 and our interest rate is 0.024. Remember, when you put your interest rate in, it's always a decimal. Compounded monthly. How many years are we waiting? How many years is she waiting? 14. Well, how do we know she's waiting 14 years? Yep, she's starting when she's 18 and she's ending when she's 32. So that'll be 14 years. Now, I always like to multiply that exponent, get that taken care of. So I'm going to make that 168. I don't need logarithms or anything on this, so just 500, parentheses, 1 plus 0.024 divided by 12, close the parentheses, and raise it to the 168th power. She's ending up with $699.43 when she goes back 14 years later. Number two. Which formula do I use for number two? The first one. Because if it's not money, I'm never going to be using that one. That one's only for money. So here we go. Francie starts with 90, but she wants to end up with 900. The growth constant is 0.2468, and I want to know how long it takes. What? What's step one? Divide, absolutely. We've talked about that many, many times. Always, always, always get rid of this extra number, so I'm going to divide those sides by 90. So that gives me 10. That works out nicely. 10 equals e to the 0.24618. Now, what am I going to need to do to solve for t? Look where it's at. It's out here in the exponent. You're going to need logarithms to solve it. And since there's an e in the problem, I won't use log, I will use ln. Now, what is the beauty of that? That cancels. So, 0.24618. And I'll just take my calculator out, divide by that, and that will be my answer. So, L10, do not forget to close the parentheses here, unless your calculator does it automatically. Divided by 0.246. So it looks like 9.33. Let's turn the page. Remember, the actual quiz has only 2 problems. We're just doing a little extra practice here. So number 3. Which formula for problem number 3? Second one. Use this formula again. What interest rate is necessary to triple your money in 25 years if interest is compounded quarterly? Do I know how much money I'm starting with? No. All I know is that whatever I started with, I'm ending with triplet. So pick a number. 5. If I start with $5, then I'm going to end with 15. It does not make any difference what number you start with, and you're going to see why in a minute. I am compounded quarterly, and I'm going to do this in 25 years. Okay, now remember, the first step to solving this equation is going to be to divide by 5, right? And when I divide by 5, I'm going to be left with 3 over here. Would you agree with that? Now, suppose we started with $10. Then we would end up with $30. Would you agree with me? But the first step is to divide. So won't I end up right here anyway? So that starting number, if they don't give you a starting number, make one up. And in this case, just know that you're going to end with 3 times that much. Because you're going to turn around and divide. Now we're here. Now we haven't seen one like this, I don't think. Am I going to need logarithms? No. When is the only time I need logarithms? I am not putting a log into this problem unless what? My variable is up here. I call it upstairs. If your variable is upstairs, if your x is up here, then you need logarithms. My x is not up there. My x is part of this fraction. Okay? So here's what I'm going to do. I've got to get it out of that parentheses. So I am going to take the 100th root of both sides. Okay, now, before you start panicking, remember you're sitting there with a $100 calculator. It will find a root for you. Okay, so no panic. It's ugly, but no panic. That means the 100th root of 3 equals 1 plus r over 4. Because these are going to cancel. Now, before we start pressing buttons, think about solving this equation. Aren't you going to take this number, subtract 1, and then times by 4? Isn't that what you're going to do to solve that? So I need to get this number on my calculator. We talked about this before. You have on your, if you have a calculator like mine, you have to type in the 100 first. And then you go to math and find that button. That's your math button. If you have a calculator like mine, press 100, press that button, then press 3 and equals. If you have a newer calculator, you just press this button and it gives you boxes to fill in and you just fill in. Either way, you should have come up with 1.011. Okay? Leave it there. Just leave it there. Don't round it off. That's this number. Now, how did we say we were going to solve now? We're trying to get r by itself. So we're going to subtract 1. So just go ahead and get minus 1. And then to get r by itself, you're going to do times 4. And your answer, it says what interest rate? I got 0.04418. So the interest rate will be 4.418%. The answer came out as a decimal, but it said, what is the interest rate? So I gotta move it a couple places and get my percentage. Okay, so if this had been, if instead of 100, if this exponent would have been 75, we would have done everything exactly the same, except we would have taken the 75th root. Right? All right, last one, number 4. Which formula do I want for problem number 4? First one. How many grams of a 48-gram sample? So I'm starting with 48. The K constant is negative 0.1234, and I'm going to wait 19 years. So I'm just solving for how much is left, right? Type it in. There's nothing to do here except just type it in. So 48, second ln is how we get E. So 48, second ln, negative 0.1234 times 19, and it looks like 4.60 grams. The question was how much is left? 4.60 grams. All right, tomorrow's quiz. 2 problems like those. My guess is one of each formula. All right, let's get our practice tests. You don't have them yet? I'm going to give them to you.
This is tomorrow.
This is tomorrow. It'll be 2 probably half-sheet paper, just like what you just did. 2 problems. I'll give you the formulas. They'll be on the board. Do not waste time memorizing the formulas. Just make sure you know which one to use.
I'm good with it.
Did I give you extras? You guys got them? You got them? Started on that. But we just finished going over that. Again, yesterday's video that some of you didn't watch, yesterday's video was lots of these word problems, so watch it if you can. You can find the time. Here we go. Problem 1, practice test 1. Consider this equation. Is it growth or decay? Is it growth or decay? It is growth. What is the percent growth or decay? 2%. What is the initial value? 3. Easy. Write the equation of the exponential function containing 0, 2, and 218. Now, before you start, make sure you remember that this is your goal. That is an exponential function. You need to find A and B. But really, you don't have to find A. If you remember that A is what? Always this number right here. So you don't even need to find that, but you do need to find B. And how do we find B? We plug in the other point. So 18 equals 2 times B squared. Remember, that ordered pair is X and Y. So those numbers are going in for X and Y. Okay, how do we solve that? Divide by 2.
Should I get a pass from?
Front office,
Okay.
quickly. And then how do I solve that? Square root. So B equals 3. And then write your answer. Y equals 2 times 3 to the x. And stop right there. Don't do anything else to that. Okay? All right, now we have, a big section of simplify. Some of these are easy and some of them are not so easy. I think A should be easy for you. What do we know about negative exponents? It flips. So instead of having 8, we're going to have 1/8. And 1/8 squared is 1/64. Isn't B the same thing? So B is going to be 4 cubed, 4 over 1, and 4 cubed is 4 times 4 times 4, 64. If you don't have it memorized, I have to figure it out. This is no calculator. This is what we're doing now. We'll get to the calculator part. C, oh my gosh, if you miss C, I don't even, it's hopeless. It's hopeless. Because what happens with an ln and an e touching each other? They cancel, so the answer to C is 5. D, you can do a couple different ways. I like to set it equal to x. So that's what I'm trying to figure out, is right, what is it equal? And then I can loop-de-loop. And it says 4 to the x equals 16. And then it's pretty obvious, x has to be 2. So the answer is 2. All right, now E is another negative exponent. So that's going to be 1 over 27 to the 2/3. Remember, we never flip the exponent, we just make it positive. Now, what does it mean to have a fractional exponent? It's a radical. So I'm going to have a 1/27th under my radical. It's going to be a cube root squared. Right? What's the cube root of 1/27? 1/3? Right? The cube root of 27? And then I have to square it. So the final answer to the problem is 1/9. What do you want to do with this? Oh, you were with Mrs. Bourne?
I was at the signing stuff.
Oh, okay, I see. Yeah, I got it. Okay. We have to start cleaning this up. What do you want to do? Lots of options to start. What do you want to do first? So that's what I like to do. I like to clean this up first. So I got a 2 and a 3. Now, these guys don't move, but they do cancel. If I have 3 on the top and 4 on the bottom, I'm going to be left with 1 on the bottom, aren't I? This is actually going to move. He's actually going to come down here, right? So 4 of them are coming down, but there's already 1 down there. So I'm going to have 5 down there. Don't forget though, you still need to square it. You could have squared it first. Some people like to do it that way, it doesn't matter. You simplify and square, either order. Okay, 2 squared is 4, 3 squared is 9, x squared is x squared, and y to be 10. So there is our final answer. G is another one that if you miss it, you simply haven't studied, because G is another one of our properties. And what do we know? When the 2 and the 2 match, the answer is 9. Yeah, whatever that other number is. So, yeah, G is 9. H. You can do this however you want. I like to set it equal to X personally. I know that my base here, since there is no base, I know it's 10. Right? If it's log, it's base 10. And then I can loop-de-loop, so 10 to some power is 1,000. That means 10 times 10 times 10, how many times is going to make 1,000? 3. So the answer is what's going to happen with I? Flip. So it's going to be 3 halves to the third. Right? And 3 cubed is, and 2 cubed is done. Oh, J's another one. Oh my gosh. When an E and an LN are in direct contact, they cancel. So what is the answer to the last one? Oh my. All right, how do we solve problems? What do you want to do with that? What? So 3 to the second equals x minus 2. 3 to the second is 9. So x equals 11. You should not be copying that down. You should be able to do that by yourself. That one is pretty easy. All right, B. What is always step 1? Divide by that extra number. If there's an extra number out in front, I want to get rid of it. So I'm going to divide by 3. So 2 to the x equals 8. Now that's pretty easy. 2 times 2 times how many 2's makes 8? 3, 2 to the third. 2 times 2 times 2. equals a number. Log equals a number. But when I loop-de-loo it, what base am I going to use? I need a base. What's my base? E. That base is E, right? So E to the 1/3 equals X. And that's the answer. Remember, no calculator, relieving by itself. Ideas? What? Can't move the exponent to the front unless I have a logarithm, and I'm not doing anything with logarithms until I divide. You gotta divide first, guys. This is a common theme. If there's a number hanging around in front, divide it out. So 1/2 to the x minus 1. Tell me about 9/36. 1/4. Now, Gabby, I could take the logarithm of both sides, but remember, this is a no calculator section, so I really don't want to do that because I don't know what the log of 1/4 is, right? I don't know. So, look at it carefully. Is 1/4 a special number in this problem?
Just get the squares of both sides. And 1/2 would be, or 1/4 would be,
Yeah, 1/4 is 1/2 squared. And why is that good news? Because as soon as these two match each other, what do? I build an equation out of the exponent. So x minus 1 equals 2, and x equals 3. All right, let's look at problem E. This one looks a little bit better. What do you want to do? Combine the logs, right? Because we are not allowed to have two logarithms on the same side. So we're going to combine them. How am I going to combine these two things since that's a minus? It means these are going to be divided. So x plus 1 over x. Now once you get that done, we can do our very favorite thing, which is loop-de-loo. So 3 to the second equals x plus 1 over x. So 9 equals x plus 1 over x. How do I solve that? I gotta be able to solve that. Multiply by x. So 9x, multiplying by x, 9x equals x plus 1. Then subtract x, so 8x equals 1, and x equals 1. Problem F. Do we have the same kind of issue? Are there two logarithms over here? Hey, we don't want that. So am I putting together? So the log base 6 of something equals the log base 6 of x. How are these gonna go together? Is it another division? It's another division, this divided by this, because that is a subtraction. Now, this is where things are a little different. This problem that we just did a little bit ago, when I put my logarithms together, it looked like this. That's a plain number. So I could loop-de-loo it. This is not a plain number, so you're not gonna be loop-de-looing in that. What are you gonna do instead? This one's actually easier. You're just gonna get rid of those, right? And make an equation out of the leftovers. All right, how do we solve that? Divide by x. So 3x minus 2 equals x squared. Yet it's set equal to 0. So I think I'm gonna go that way, and subtract 3x and add 2. So 0 equals x squared minus 3x plus 2. What in the heck do I do with that? What?
Factor.
Factor. So two answers, x equals 2 and x equals 1.
Both of them always work.
Nope. These do. But remember, this, and this, and this all have to be positive. So as long as I get a positive number when I plug in, I'm all good. All right, next problem. ln x equals -1. Loop-de-loop. What's my base? E. So e to the negative first equals x. That's it. Except I'm not allowed to have a negative exponent, so I'm going to rewrite that as 1/e. That's it. We have done enough of these that you should look at this problem and something should immediately pop into your head. You see a 27 and you see a 9. 9 is 3 squared, 27 is 3 cubed. That's what needs to pop into your head. So I have 3 cubed to the x equals 3 squared. That is exactly like what happened over here. As soon as you have log base 6, you drop those out and look at just the other part. As soon as you have 3 and 3, you're going to drop those out and just make an equation out of the exponents. You can't do the problem if you don't make these match. So you've got to recognize 27 and 9 and you need to match. All right, last one. This is a big section. Lots of problems in this section. Last one. What are you going to do with that guy? equals 9, so x equals 3. That was easy enough. We're going to write as a single logarithm. So in other words, it's going to be log something. Okay, do you remember what to do with this? 4 is an exponent. So this is the log of m to the 4th minus the log of n. Wait, how did those go together? We just talked about it. They're going to go together through division. So your answer is going to be the log of m to the 4th over n. It's a division problem. Did you check in with my desk? This is not a class you want to listen to. All right. Now, 6 is exactly the opposite. 6 is one we are going to split up. So we're going to have, since there's 2 letters, we're going to have 2 logarithms. So we're going to have the log of x and the log of y. We're going to have a logarithm for each letter. Expand. Now tell me about this. Is there anything I need to do with that x, that log x? Put a 3 in front of it. Put a 2 in front of the log y, because that's where exponents go. And they're being subtracted because that is a division. So these 2 problems are opposite. Same idea, but opposite. All right, now we need a calculator. Actually, we're not gonna get this done, so we'll wait on part 7. Let's go to part 8. Let's go to the word problems, since we have a quiz tomorrow. Do a little more practicing. Here are my formulas. All right, so 8A. How long will it take for an investment of this to go into this if the bank pays this interest compounded daily? Which formula? My number 1 or my number 2? Number 1. Compounded daily. So I'm going to end up with 10,000. Starting with 6543. My interest rate, remember 2 decimal places, 0.01875. If I'm compounded daily, what's my N? Daily? 365? Aren't there 365 days in a year? How long it will take. Now again, these numbers look terrible, but you do not have, you can type it in on a calculator. It's real simple. What are we going to do first? We're going to divide. We always divide first. So I'm going to have 10,000 there's no benefit to LNing. There's only a benefit to LNing if your problem has an E in it. But you can do it. It won't make it any easier or harder. I'm gonna log. Now again, I am not freaked out about this at all. I have a calculator right in front of me. Okay guys, go back 50 years when your little Lisa sitting in a classroom like this, you start freaking out because you don't have a calculator. But you guys have one, so it's easy. Right? It's easy. What happens to this exponent? When I take the logarithm of it, what happens to that exponent? It goes to the front, and that is why I did it. So I'm going to write all this down again. We're going to go to our calculator. Okay, so first we divided by the 6543. Then we took the logarithm of both sides. Then we pulled the exponent out in front. So this is now what it looks like. Okay? Now, you don't need to write anything else down. I need you to pay attention to what's happening here. This is what you're trying to get by itself, right? So to get that by itself, don't we have to divide by 365? So I'm going to type into my calculator, I'm going to type log, here, into these two things. We have a quiz tomorrow. I'm going to type log 10,000, make sure you get enough zeros, divided by 6543. Okay, so this number. Now I'm going to divide it by 365. Okay, so everybody do that with me. Type this thing in right here. Make sure you close the parentheses. And then divide by the 365. I'm going to divide that over here. And I got 5.047 with an E negative 4 at the end of it. So everybody's doing this. Everybody's typing this in, dividing by 365. Okay? Now that's gone. I'm still trying to get T by itself. So what do I need to do now? One more step. Don't I need to divide by this? So divided by log 1 plus 0.01875 divided by 365. And if you got your answer as 22.16 years, you are right. So, once again, once we had our setup, we of course divided by this number because that's what we do. Always. Then we took the logarithm of both sides and pulled the exponent off in front. So then it looked like this. We're solving for that. So we took this number, divided it by 365, and then divided, we had two divisions, we divided by 365, and then we divided by all of that. That gave us that answer. All right. Yep.
You said that in the video, if it looks like the second equation, but it says constantly, it'll be per.
Yep. Yep. If it says continuously, it is a problem. Okay? All right, B, quickly, let's see if we can get these two done. How much will be in the account at the end of 50 years and 125 is invested at this interest compounded monthly? Do I want the same formula I just used, or do I want per? The same one. Same one. So how much will be in the account if 125 is invested at 0.03125, remember you're moving the decimal point 2 places, compounded monthly for 50 years. are we going to need logarithms to do this problem? We're just gonna type it in. Now, I like to take care of this first. I'll make that a 600, 12 times 50. And then I just type in exactly what I wrote. So 125 parentheses, 1 plus 0.03, 125 divided by 12, close parentheses, raised to the 600th power, and I got $595.13. How about you? Same formula, a lot easier to type it in because of where the variable was. All right, last one. I know we still have to do part 7, but we'll do that tomorrow. How long will it take for 1,300 algebites to grow into 3,100 algebites if their growth constant is 0.101? Which formula? Correct. So I need to end up with 3,100 if I'm starting with 1,300. And their growth constant is 0.101, and I want to know T. How long will it take? Am I going to need logarithms? You betcha, because my variable is the exponent, right? But not first. What am I gonna do first? Divide. So 3,100 divided by 1,300. You want to go ahead and cancel out those zeros, that's fine, but you do not have to. You can leave the whole fraction if you want. Now what? ln, I would definitely ln both sides. So ln 31/13 is going to equal 0.101t. LNs don't cancel unless they're touching the knee. If they're touching the knee, they cancel. So what am I going to do? ln 31/13 divided by 101. And the question was, how long will it take? 8.60. We will finish number 7 tomorrow, and we'll go on to practice test 2 after we take our quiz.